Alright, hey guys, what's up? So obviously I'm not around here today, but you guys are going to be doing a lab based on Hess's law. So there's just going to be a few things I want to go over with you really quick, just so you're on this page and can do this, well, without me there. So first of all, hopefully that you have the lab reports that were passed out on Hess's law from the sub. If you don't, hopefully you'll get it very soon. Now, as you'll notice, I am wearing my goggles, I have gloves on, my hair is tied back, and of course, optional lab coat. So these are some of the things that you definitely want to get or put on. Specifically, if you are going to be dealing with the chemicals, gloves, absolutely, because it's going to be hydrochloric acid. Now, same thing, even if you're at the tables, please make sure to wear goggles, right? I got these here, these are mine, but we do have some other ones here, of course, found in the back, right next to the gloves. Oh, sorry. Which is right next to the 1 molar hydrochloric acid. So all this stuff and the beakers, or sorry, the graduated cylinders that we need, are all back here in the back, all right? So that's where you can find the acid and the gloves, all the safety gear. Now, once again, you don't really need to wear the lab coat, sorry, but if you do want to, remember it's in my back room, right over there. You guys can definitely get that, put them on if you do want to save your clothes. Now also, as you can tell, my hair is tied back because if I'm doing this lab with you guys, I don't want to have my hair accidentally fall down and of course go into any acid. So if you do have particularly long hair, you might want to tie it up just in case. Now, this lab, you will need to use the calorimeters as well. So where can they be found? Well, right in the back, right here, where we have all of our acid gloves, goggles, everything like that, down in the drawers. You will notice it is labeled, oh, can't really see that. Oh no, that's probably backwards. Calorimeter. So open these up. Boom. You will find them right here. So we do have enough calorimeters for about 12, I think, 11 or 12. So depending on how many you are in class right now, that could easily be 2 to 3 per group. If you feel like doing it for table groups, go ahead. That's fine. And of course, thermometers are set up right there as well. All right, so we have our calorimeters, our thermometers, all of our safety stuff, our acid. Now, the lab that we are doing is we're going to use Hess's law to figure out the molar enthalpy of combustion of magnesium. Now, magnesium itself, when you burn it, it is a formation reaction, so it's not technically burning or combustion, it's a formation reaction of magnesium oxide. Now, that reaction itself is one of those ones that we cannot measure the enthalpy change because it's just a little too hard to do. So we're going to use Hess's law. So our first reaction you're going to use in your calorimeter, you're going to use magnesium oxide powder, and we're going to react with hydrochloric acid and get the enthalpy change. So the magnesium oxide powder is going to be found on the left-hand side of the room next to a balance, and it's in this stuff right here. So you're going to pick up the magnesium oxide powder and place it into your calorimeter using this little thing here called a scupula. All right, now you might want to put on gloves for this as well because this stuff is very powdery. Like think of flour except even finer. So it does kind of stick to your hands and it'll stick to your clothes, which you don't really want. It's not a dangerous compound by any means like by any stretch of the imagination. It's not dangerous, but you still don't want to have all that stuff on you. So definitely when you're using that, whoever's doing it, wear your gloves. Right, so just in case, as soon as the reaction's done or you're done picking it up, you can just discard your gloves and don't have to worry about all that powder kind of on your hands, and you might get it on your face, your mask, and all that stuff. So that'll be your first reaction, where just read the procedure, make sure you take the initial temperature of your hydrochloric acid, you dump that in, of course, record your volume, you do that, and then get your temperature change, and you can get your enthalpy change based on that. Now, once that reaction's done, you are going to clean out your calorimeter, all right? So just rinse with plenty of water, that'll be fine. The next one you can have wet, so if your calorimeter's not completely dry, that's fine. And our next reaction is going to be, we are going to figure out the enthalpy change for the reaction between magnesium solid and hydrochloric acid. So same thing, you are going to have to collect another bit of hydrochloric acid right from your graduated cylinders. So you can use the exact same graduated cylinder as well. You're not going to contaminate them because you're using HCl for both. Now for the magnesium, it's down in the back right-hand corner of my room over here next to the other balance. All right. Now for the magnesium, we are using magnesium ribbon, which looks like this. Now this is coiled up. So you are going to uncoil this and take about 15 centimeters of magnesium ribbon. Now, how would you know when you got 15 centimeters? I got a ruler back here. Now, you don't need to have exactly 15 centimeters. If you're off by a little bit, that's perfectly okay as well. Because after you measure that out, you are going to then weigh it on the balance, which again is right here. So remember to click the tare function first, because you do not, right now it's reading, yeah, you can't see that. And I'm not going to fool around with my phone there now. It's reading 0.03 grams, so I don't want to have that there. So you tare it out, you weigh it. Then what you're going to do is coil it up as tightly as possible, put it in the bottom of your calorimeter. Then you are going to pour your poured acid from your graduated cylinder onto it and check the temperature change. Now, this reaction, don't be alarmed if you hear a lot of fizzing. That's fine. That's just hydrogen gas being released by the reaction. So that just means as well, because where we have the stopper on it, or the top from our calorimeters, that means when you first open up the cover when the reaction's done, just don't have your nose too close to it. Hydrogen gas isn't poisonous, nor is it dangerous. It's highly flammable, so make sure no one has any lighters around. Yeah, I just gave you guys a bad idea. Anyway, no open flames. All right, but hydrogen gas will it does irritate your nose a little bit. So as you're opening up, just make sure it's far away from your face. Hydrogen gas will go off and then you're fine. Same thing, when the reaction's done, you can safely toss everything down the drain, rinse everything out, put the calorimeters back where they are. As with your graduated cylinders, once they're done as well, rinse them out, put them on the glass drying rack just like you did before, and basically, lab's done. You're gonna have two sets of data, right? So you're gonna have hopefully your enthalpy change for your first reaction and your enthalpy change for your last reaction. You're going to use those enthalpy changes along with, and you're gonna see it in your lab there as well, one for hydrogen and oxygen, right? So that'll be the last one down here. So you're going to apply Hess's law, and the net equation's given, so you're gonna have to rearrange and all that, and then eventually use Hess's law to determine the enthalpy for the combustion of magnesium, or the formation of magnesium. All right, so hopefully that gave you a good idea on what you need to do. Now, as for the calculations, if you don't get all of them done, or you just have trouble with it, fire me off an email and we can definitely hammer those out. I can probably make a video on how to solve using the information that's there, whatever. But definitely for this class right now, get the lab done. Try the calculations as best you can. You should be able to do the Hess's law portion and answer the questions along with it. Now, just because I'm not going to be here, and we're going to have a quiz coming out really soon, so there won't be a performance task based on this lab. All right, so I might just toss an extra question, or who knows, we might just do another lab for the end and get a performance task, but either way, so don't worry about a performance task with this lab. I will probably pass that out as just kind of this is what it would have been. All right, so that'll be the lab. And last but not least, just with safety. So if you do accidentally waste any hydrochloric acid on the floor or on yourself or anything like that, rinse it with plenty of water. If it's on the floor, just paper towel it, make sure to put plenty of water down, wipe it off, that same thing. If you get it on your skin, right, that's why you're wearing gloves, but if you do get on your skin, just go to the tap, plenty of cold water. And same thing, if you do get it in your eye, it's always a possibility. If you're wearing goggles, it shouldn't. Just make sure to turn on the tap, cold water, but also don't turn the tap on bust, because you've seen the water come out of those. It'll probably take your eye right out of the socket. But just stick your eye underneath there and rinse it out. It should be fine. Like I say, we're using kind of dilute solutions, so the safety-wise, you want to be cautious. But anyway, if you do waste it anywhere, make sure to clean it up properly. All right, that'll be the lab. So if you have everything set up, get yourself in your groups, and you should be able to start and hopefully get all your data and do up the calculations when you are done. All right, so that'll be it. See you guys later.